How to copy a 2D array into a third dimension, n times? I'd like to copy a numpy 2D array into a third dimension. For example, given the 2D numpy array, convert it into a 3D matrix with n such copies in a new dimension. Acting on or with n equals 3, the output should be
Probably the cleanest way is to use np.repeat. Having said that, you can often avoid repeating your arrays altogether by using broadcasting. For example, let's say I wanted to add a 3 vector to A. I could copy the contents of a 3 times in the third dimension, then copy the contents of C twice in both the first and second dimensions, so that both of my arrays were 2, 2, 3, then compute their sum. However, it's much simpler and quicker to do this. Here, a ... none has shape 2, 2, 1, and C none column has shape 1, 1, 3. When I compute the sum, the result gets broadcast out along the dimensions of size 1, giving me a result of shape 2, 2, 3. Broadcasting is a very powerful technique because it avoids the additional overhead involved in creating repeated copies of your input arrays in memory. Although I included them for clarity, the non-indices into C aren't actually necessary. You could also do a ... none plus C, i.e. broadcast a 2, 2, 1 array against a 3 array. This is because if one of the arrays has fewer dimensions than the other, then only the trailing dimensions of the two arrays need to be compatible. To give a more complicated example,
another way is to use numpy.stack. Supposing that you want to repeat the matrix a num_repeats times. The trick is to wrap the matrix A into a list of a single element, then using the operator to duplicate the elements in this list num_repeats times. For example, if this repeats the array of 1, 2, 1, 2, 5 times in the third dimension. To verify, in IPython. At the end we can see that the shape of the matrix is 2 by 2, with 5 slices in the third dimension.
Use a view and get free runtime. Extend generic ndim arrays to n+1 dim. Introduced in NumPy 1.10.0, we can leverage numpy.broadcast_ to simply generate a 3D view into the 2D input array. The benefit would be no extra memory overhead and virtually free runtime. This would be essential in cases where the arrays are big and we are okay to work with views. Also, this would work with generic NDIM cases. I would use the word stack in place of copy, as readers might confuse it with the copying of arrays that creates memory copies. Stack along first axis. If we want to stack input R along the first axis, the solution with np.broadcast_to create 3D view would be stack along third/last axis. To stack input R along the third axis, the solution to create 3D view would be. If we actually need a memory copy, we can always append .copy there. Hence, the solutions would be Here's how the stacking works for the two cases, shown with their shape information for a sample case. Same solutions would work to extend a ndim input to n+1 dim view output along the first and last axis. Let's explore some higher dim cases. (3D input case). (4D input case). And so on. Timings. Let's use a large sample 2D case and get the timings and verify output being a view. Let's prove that the proposed solution is a view indeed. We will use stacking along first axis. Results would be very similar for stacking along the third axis. Let's get the timings to show that it's virtually free. Being a view, increasing n from 3 to 3000 changed nothing on timings and both are negligible on timing units. Hence, efficient both on memory and performance.
This can now also be archived using np.tile as follows.
If you want to see more, please consider subscribing.